Hello everyone, this is Tiger again. Today we are just here to talk about the second half of the JMC paper of the year 2014. So this is pretty much a challenging half paper, I would say, because there are many harder questions in this half. So let's take a look at how we might solve them. All right. So for question number 16, it is definitely a logical deduction question, which belongs to the miscellany module. And I would say that it's a logical deduction question on truths or lies. All right. So you can see that, well, 5 statements. That's what they have in this question, and it says that only one is true. So you can immediately eliminate the first one, saying that B is true, because if it is true, then B is also true, meaning that there will be more than one true. So A is not possible. C is definitely not possible either, because if all of them are true, then of course there will be more than one true. And of course, you can immediately eliminate D, which if all of them are false, then not a single one of them is true. So these 3 are contradicting with the question. Now we just have B or E left. All right, so let's take a look at B. B says that E is false. So if B is true, if B is true, if B is true, then E is false, which E says that A is false, which means A is true, because E is false, right? So this statement is false, which means A is the opposite of false, which is true. So that is contradicting, because there will be 2 truths. So it means that B cannot be the correct answer, and the correct answer will be E. So now let's see how E works, all right? So if E is true, it means that A is false. If A is false, then this statement is false, which means that B is the opposite of true, which is false. So B is false, which means that this statement is false. So E is the opposite of false, that is true, which matches the assumption we made that E is true, right? It comes back to this conclusion. So E is the true answer in this question, all right? That's for question number 16. And then I might need to hide my hat for this one. So for question number 17, again, it's a miscellany question. And it's going to be on the 7 bridge problems, or the application of it. So you can see that you need to travel through all the stations in this map, where according to 7 bridge problems, it can't be, like drawn in one sketch, because it has too many odd number points. Because we know that if you want to draw this diagram in one sketch, then each of these intermediate points should be having an even number of connections, which means that the number of incoming routes will be equal to the number of exiting routes, right? So that's why we need an even number, because if I'm going through a point, I need to go in it and go out of it. So you can see that all the ends are definitely odd number points, but then we can start or end at the ends, right? So that's going to solve the problem somehow. But then we can see that there are 2 of these nasty points, which are these 2, where both of them are connecting 3 3 of the lines, which means that they would be at least revisited once. So if I am to revisit these 2 points, it means that, well, probably we can just think about this diagram as something like this, if I'm simplifying it, right? Where these 2 points are the 2 junctions there. So definitely, if I need to go through it, I will have to go through the other part as well, right? Like the other part of the branch. So it means that I am always taking the shorter part of the branch to repeat it, such that I'm going through less of the stations. So I am first going from there to there, and then from there to there, and then turning back, and then going down, and then I'm revisiting this part, coming up, finally ending my trip, which means that actually I would have revisited 1, 2, 3 stations during my trip, because the end point, well, we are just visiting it once, even if I'm turning back, right? So the answer is going to be 3. The answer is going to be 3. And then for question number 18, this one's a bit simpler. So I would say that this is a numbers and operations question on BITMUS. But not necessarily BITMUS, because we don't have to calculate it like completely. But of course, if you want to, you can do that, but it's just not necessary. And I'm just going to let you know that 5 to the power 6 is 15625. But that's not important, because we just need to do the last digit analysis. We know that 5 to the power 6 is ending with a 5, right? No matter how many times 5 is multiplying itself, the product is always ending with a 5. Now I'm adding 1 to it. So 1 adding 5 to the power 6 ends with 6, of course. Now I'm subtracting either 4, 5, 6, 7, or 8 right there. Yeah? So if I'm subtracting 4 from 6, I get a 2. If I'm subtracting 5 from 6, I get a 1. If I'm subtracting 6 from 6, I get a 0. If I'm subtracting 7 from 6, well, we know that that's just the last digit, right? So we can pretend that I'm borrowing a digit and using 16 take away 7, so it's going to end with 9. 16 take away 8 is going to end with 8. Then we are comparing these 2, 1, 0, 9, and 8 with these last digits of the answer. And you can see that only 8 is going to match up. 16 take away 8 ends with 8. So the answer is going to be E. All right, if you just look at the last digit of it. Okay, so that's how you can find the answer. And next, for question number 19, so this one is also pretty simple. I would say that this is a miscellany question as well. And it's going to be on sports competitions, which is also part of the logical deduction questions. So we can say that it's a sports competition question. So it says that the winner was awarded 2 points and the loser 1 point. And no games were drawn. Which means that either is going to win, like the player is going to win or lose. So now it says that Jack won 4 games exactly. So if Jack wins 4, it means that Jill loses 4. right? And Jill had a final score of 10, which means that if Jill is losing 4 games, she's going to gain 4 marks from these 4 games, right? So the winning scores for Jill is going to be 10 take away 4 equals 6 marks Jill gets for wins. All right, and we know that each winning is going to get 2 points. So if I do 6 divided by 2, we can see that it is 3 games won by Jill. Now Jill is losing 4 games and Jill is winning 3 games, which means that altogether there should be 7 games, right? So the answer is going to be 7. So that's how we can complete question number 19. All right. And as for question number 20, so this is going to be algebra. This is definitely algebra, you can see. And this is about using letters to represent the unknowns. So now it says that box P has P chocolates, box Q has Q chocolates, where P and Q are both odd and P is greater than Q. So it means that, well, P and Q are odd numbers. There is more chocolate in box P than box Q, right? So it is asking you what is the smallest number of chocolates which would have to be moved from box P to Q, so that box Q has more chocolates than box P. All right, so if they are both odd, it means that the difference between them has to be an even number, right? Say, for example, 5 chocolates and 7 chocolates in 2 boxes. So how many chocolates do you need to move from the 7 box to the 5 box to make it has more chocolates? So first of all, you would like both boxes to have the same number of chocolates first, right? So box P just need to move half the difference of chocolates to box Q to make them the same, right? For example, like 7 to 5, you just need to move 1 chocolate to make both boxes the same, which is like 6 chocolates in both. And then you need to move 1 more chocolate to make sure that the originally fewer box now has more chocolates. Okay, so basically the first step is that we can find the difference between the 2 boxes, which is P take away Q. So that's the difference in the number of chocolates between 2 boxes. And if you divide it by 2, it means that this is going to be the number of chocolates moved to balance the 2 boxes. Now, after moving half the difference from the box that has more to the box that has less, they are going to be the same. Now that they are the same, I need to move 1 more, right? So I'm just going to add 1 to the number. And we know that 1 can be written as 2 over 2. If you just try to find the common denominator for both expressions. So you're going to have P take away Q adding 2 over 2, which means the answer is going to be B, all right? The answer is going to be B.